Alright guys, so I'm having technical difficulties here. Once again, I thought I was recording as I wrote, and it didn't. So, I'm going to have to walk you through what I already have written on here again, and hope that this last one that I'm going to try with this particular software will work for me. But just so you know, from this week forward, I'm going to be using a different application which will hopefully work a little better for me, and you'll be able to see what I'm doing step by step as I go. Also, I'm leaving the previous instructors' videos out there as well in the hopes that combining my sort of half-assed videos here and his, hopefully the material will get across to you guys. Okay, so this is number 89, again on page 68. So we're looking at an expression with fractions here. And so this was our starting problem. There's a couple of different ways that you can actually tackle doing this problem. You could either rationalize the denominators right off the bat, because you're not supposed to leave radicals in your denominators, if you remember, or you could make all of your denominators the same radical first, and then combine them together, and then worry about rationalizing later. It really does not matter. What I've chosen to do is to rationalize the denominators first, just because I find that to be a little bit easier in the long run. So I'm going to start with my first term here, this 1 root 2. If I look at, that's this line here. So in order to rationalize the denominator, I've multiplied the top and the bottom by the square root of 2. So that will give me 1 times the square root of 2 over 4, or 1 times the square root of 2 over 2, because that's what the square root of 4 simplifies down to. This 1 does not need to be there. You could just write it as the square root of 2 over 2, because 1 times anything, as a reminder, is itself. Okay, so now we're moving on to this term, which is this line right here. In order to rationalize the denominator, I'm going to multiply the top and the bottom by the square root of 8. So, once I've done that, I've got 3 times the square root of 8 on top. The square root of 8 times the square root of 8 would give us the square root of 64. I've kind of skipped that step that I did up here, which the square root of 64 is just 8. So hopefully you're seeing a pattern here. When you multiply a radical by itself, essentially, you get that number that's not underneath the radical. So that was a bunch of words that probably didn't make sense. Let me try again. So we've got the square root of 2 times the square root of 2. That gives us just 2. The square root of 8 times the square root of 8 gives us just 8 without the radical. All right, and then again, another example is our last term here from our original problem. 1 over the square root of 32, multiply top and bottom by the square root of 32. That will give us 1 times the square root of 32 on top, or just, again, square root of 32. The square root of 32 times the square root of 32 is just 32. Okay, so, and unfortunately you can't, it's going to be kind of hard to tell what my original problem was here, but so this part is this part of the term. This part was this part, and then this is completely this. So now what I have to do in order to add fractions together is I have to find a common denominator. So I'm looking for the common denominator for 2, 8, and 32. And as it turns out, that is, of course, 32. Because that is the smallest possible number that can be evenly divisible by all of these. So, in order to convert a 2 to 32, I have to multiply the top and the bottom by 16, which is what I've done here. So that would give us 16 times the square root of 2 over 32. I kind of crammed in some 4's here, because 4 times 8 is what would give us 32. So that's this part, which would give us 4 times 3 times the square root of 8 on top, or 12 square root of 8 over 32. And then our last term is already over 32, so we don't need to simplify that down any further. Okay, so now, once we've got it here, since it's all over the same denominator, we can combine it and put it all together over one fraction. Again, I kind of crossed out what I did here, but that would give us this, 16 square root of 2, plus 12 times the square root of 8, plus the square root of 32, all over 32. Now, as it originally was, we could not add the terms on top together because, again, as a reminder, the terms underneath the radicals must match in order for us to do that. But what we can do is look for ways to reduce down the square root of 8 and the square root of 32 in the hopes that we can make it something times the square root of 2. So that's what I've done here. I've taken my 2 times the square root of 8, taken that up here. The largest perfect square that goes evenly into 8 is 4. So I've broken that into, again, this is that 12 out in front, times the square root of 4 times 2. So that would give us 12 times the square root of 4 times the square root of 2. So that square root of 4 simplifies down to this 2, which is what I've written here. So I've got 12 times 2, which is 24, times the square root of 2. And I'm going to repeat that process for my square root of 32 right here. I can break this into 16 times 2, which would give me the square root of 16 times the square root of 2, which equals 4 times the square root of 2. Okay, so that's why I have crossed these terms out and replaced them with these. Okay, so now I have 16 times the square root of 2 plus 24 times the square root of 2 plus 4 times the square root of 2. Now all of my stuff under the radical matches. And now I can add these terms together. So it would be, if you think of the radicals as x's, 16x plus 24x plus 4x. So that gives me 16 plus 24 is 40, plus another 4 is 44. So that gives me 44 over 44 times the square root of 2 over 32. And I can try to reduce this fraction a little bit by reducing these whole numbers. Looking for the large number that divides evenly into both, which turns out to be 4. So 44 divided by 4 is 11. 32 divided by 4 is 8. So our final answer is this 11